Hey guys, welcome back to the shop. Today we're going to build a canoe canister. I've got an idea I want to try. Saw another smith here on YouTube do something similar, but this is quite a different approach. I want to build a San Mai blade, sandwiching some 52-100 steel in between some unique pattern welded steel here using nickel plated ball chain. It's it's the dog tag chain that you hang a necklace off of, or a dog tag or whatever. So I've got some of that, and this is just steel with nickel plating on it. So I'm gonna set myself on fire here. And this canoe canister, the reason it's called a canoe canister, we'll just breeze on past the fact that I set myself on fire here and talk about the canoe canister. It's similar to the ones that I usually make, but I've enclosed it, and now we're going to cut the top out, and now you can see why it's called a canoe canister. What this does is allows us to index the materials, the contents of the canister in a horizontal fashion, which in some cases, as you'll see here, is a useful thing to be able to do, because we're trying to keep certain things in certain places aligned in a certain fashion. So I've got some 3/4 52-100 steel rod or bar here, and I'm forging it down on the power hammer to about 600 thousandths, give or take. Doesn't have to be super precise, but that's very close to 1/3 of the total width of the inside of this canister. I'm going to apply some generous quantities of white spray paint to the inside and let that dry. The titanium content in the paint will create a non-welding barrier for when we forge weld this whole thing together. Got my 52-100 steel forged out, and I'll need 3 pieces to fit the full height of this canister. And that's going to be the edge steel of my San Mai blade. Now that I've got my pieces cleaned up on the grinder, I'll put them in the canister here, center it up, and then we can start adding the pattern welded constituent of this project here. I'm not sure how well this is going to work. If you're aware, probably you are, these little balls on the chain are hollow, and I was thinking about that, and that's one reason why I went with this smaller size of chain. I didn't want to go with anything bigger that was going to create any more voids than possible, and I don't know how that's going to compress down and forge weld together in this canister, so we'll just have to see. If you forge it down enough, I'm expecting it should be okay. That's 1084 powder, just straight steel. Normally I'm using a powder with nickel content, but in this case, this ball chain has nickel plating, and that's going to be the thing that provides the contrasting pattern to that darker colored carbon steel powder, which once it's all forged welded together is just going to be solid steel. So you see how this canister goes together there? We have to make sure it's indexed properly, and we're forging it in a sandwich fashion so that our blade steel or edge steel is where it's supposed to be. We can get this in the forge now. We'll heat it up. Once it's up to a good color, I'll let it sit for another 20-30 minutes. Make sure that everything inside is up to forge welding temperature, and then we can squish everything together in the press, forge welding this entire thing together inside the can. Of course, mentioning the white spray paint, that'll keep the can from welding to that powdered steel, the ball chain, and the 52-100 steel in the middle of this whole thing. I put some welding beads on one side to try to index where my edge steel was, but as you would imagine, those kind of disappeared when they were being squished. But I was able to see where everything was at because the 1084 and ball chain kind of compressed a little bit more than the center edge steel, and it was pretty apparent where that was at. So I can forge this out into a bar. As I'm doing that, I'm starting to see some inclusions. What is the word? Some sorts of little voids on the surface, and there's always some little bit of cracks and stuff on your canister pattern welded steel, but these looked a little deeper than normal, and I got most of them out, grinding the surface out, and so we'll continue on forging the blade here. I'm going to forge the bevel in. This is important on a San Mai blade so that your jacketing material ends up relatively close to the edge instead of somewhere way up, halfway up, or within a third of the spine of the blade. You don't want that. That sort of negates the whole purpose of a San Mai. Blade shape's coming along, brushing off the residual flux here on the blade and continue on the profile here. I'm hoping that everything is centered up. Generally speaking, if you do everything consistently, you don't really have to worry about where that center steel is if you forge everything. You don't have to forge side to side. As you're forging the steel, everything's going to compress on either side more or less equally between the hammer and the anvil, but then you do have to straighten things up to make sure everything is centered on the finished product.
Hey guys, a quick break from the video to tell you about today's sponsor, FireCreekMercantile.etsy.com, which is a joint effort between me and my beautiful wife, but mostly my beautiful wife. You can get all kinds of cool stuff for the blacksmith, bladesmith, or knife maker, or just general DIYer in your family, like this cool shirt, I Heart Carbon Steel, or this cool mug, I forge stuff and I know things. Drink coffee, forge stuff, repeat. I can't stop buying tools, it's a vice. I've got one more here. I do my own blacksmithing. So go ahead and check it out, FireCreekMercantile.etsy.com. Go buy some stuff. You got people you need to buy Christmas presents for. Back to the video.
So look at this heat treated. I've done some thermocycle, some normalizing and grain refinement on this blade so we can quench it, harden the steel, and then temper it, after which we can start grinding. Everything looks to be pretty decent. First, we'll clean up the profile on the grinder and then start cleaning off all of the scale that's on the surface of the blade. Here I'm seeing some more and additional surface cracks or cold shuts or inclusions, and I'm starting to get a little bit concerned because at this point in time they're gone by now usually, so this is definitely creating a little more of a problem with this ball chain pattern welded stuff. I kept grinding on it and finally got down to where almost all of the inclusions were gone, but we started to lose a lot of our San Mai jacketing. I ended up with a blade a lot thinner than I wanted to. So I decided to take this project a little bit different direction, and we've done some chopping on the 2x4 test after putting an edge on and getting it razor sharp, and it performed admirably. But let's now step into the realm of theatrics. What else can this blade do? I've got some 1/4 inch mild steel rod underneath some brass, and I've got a hammer. So let's see what happens. I was reading a book recently, I believe it was The History of Knife Steel by Dr. Laren Thomas, and it was quoting one of the buck knives guys, one of the buck knives founders. They had a promotional picture where it showed a knife being hammered through a bolt, cutting a bolt in half. And apparently this was a real thing, and it can be done, as you're about to see here. But the original buck knives guy was quoted as saying you had to know what you were doing in order to actually do that, because you have to have a decent heat treat on your steel. You have to have the proper edge geometry, but then you also have to have the technique, which I do not have. And you'll notice here that it's very easy for that blade to twist from side to side as you're cutting through that steel. And more than anything, I think that is what really will take a chunk out of your blade and make the blade perform worse than it would otherwise. I'm having a hard time, partly because I put a crown on the spine of this knife, and it's it's not good. But like I said, this is pure theatrics. There is no reason. Oh, there it goes. There's no reason to ever do something like this with a knife, and it's definitely not designed. So I created a little stress point right there with that first cut, and then I really put the was trying to keep everything straight up and down and really hammer down on that, no pun intended, and we broke the blade. It came in half. The grain structure looks beautiful, silky smooth, looks great. You can't see any weld lines, so those 3 pieces of 50 to 100 went together beautifully in the forge welding process. And honestly, the knife performed pretty well. If I wanted to actually cut through steel rods, I would probably give myself a little bit harder heat treat. Maybe even a little bit heftier edge geometry, although this particular one isn't too bad. And then I'd have to get really good at putting everything, all that pressure straight up and down, because you can see how that blade's just twisted in my hand. The ergonomics on this handle are not anything to write home about. So there you go. There's the steel, there's the blade, and there's the pattern, which turned out pretty cool. I've noticed that the nickel plate on the mild steel ball chain didn't provide a super stark contrast because they're both sort of a lighter color. There's the end grain structure. All in all, interesting project. And hey, if you haven't ever pushed your blades to the ultimate limit, that's the best way to figure out how well you're doing on your forging, your heat treating, and what your blade can actually do. I could have done a lot of other things to this blade before just outright destroying it on the steel with a hammer. But sometimes that's kind of fun, and hopefully you learned a little something on this video. Appreciate you guys watching, and we'll see you on the next one.